I'm Anil Kumar. Welcome to my series on vectors. We are going to discuss properties of vectors in this particular video. Followed by these properties, we'll look into a very important case where linear combinations of vectors will be considered, and 3 questions where we are going to apply these properties. So these questions have been picked from test papers. I hope you find them very interesting. The next unit will be on vectors, internal and external division of vectors, and the questions which we talk about here will give you a hint of how we should do internal and external division of vectors. So let's begin. Commutative property of addition. So like we have in algebra, a plus b, if there are 2 vectors, order does not matter. So a plus b is same as b plus a. Associative property of addition. If there are 3 vectors a, b and c, again the order does not matter. Either you could add them first, a and b, or you could add a with sum of b and c. It's one and the same thing. Distributive property of addition is we are multiplying by a constant scalar, so scalar multiplication, and we have 2 vectors, let's say a and b. Now, product of k, scalar multiple of k with a plus b is same as scalar multiple of k with a plus scalar multiple of k with b. So that is distributive property of addition. Adding 0 means the vector does not change. If vector a is added with vector 0, we get vector a itself. Associative law of scalars. Now, the wordings are very important here, since in many tests, they may give you a multiple choice question with different wordings, right? So, when we say associative law for scalars, 3 things are involved. Associative means 3 things. In this case, there are 2 scalars. We could have m and n as 2 scalars multiplied, that is scalar multiple. This could be written also as m times n times a, or it could be n times ma, right? So order doesn't matter. That's what we're trying to say here. Now when we say distributive law for scalars, now distributive law of scalars is that we have 2 scalars, let's say m and n. If you add them and then multiply by vector a, it is same as m times vector a plus n times vector a. So these are the properties. Now basically what you saw here also is when we add them up, it becomes a linear combination, right? So now we'll take linear combination of vectors, and with the help of these examples we'll elaborate further on it. So we have 3 questions here. Question number 1 is PQRS is a quadrilateral where x and y are midpoints of PQ and RS respectively. Show that PS plus QR is equals to 2xy. So that is the first question. The second one is a trapezium ABCD has AB equals to A, BC equals to B, AD equals to 3B. E and F are points on BC such that the ratio of BE is to EF is to FC is M is to N is to 3. Find BE, EF and AF. Question number 3 is if A has coordinates -1, 2, 3 and B has coordinates 2, 4, 6, find the position vector of D which divides the line AB in the ratio of 1:2. Now these questions are very tricky. I like you to pause the video, copy questions, solve, and then look into my videos. So let's begin by solving the first question. Question number 1. PQRS is a quadrilateral where x and y are the midpoints of PQ and RS, right? So these are the midpoints of PQ and SR. Show that PS plus QR equals to 2xy. Now there was a typing error, I just corrected this. Now we can actually find the expression for xy considering clockwise combination. That is to say, if I move in this direction, I can write what xy is. And also, if I move in this direction, counterclockwise, I can find by linear combination what xy is. So xy can be written as, if I do counterclockwise, we can go like this: xp plus ps plus sy, right? Similarly, if I go in the counterclockwise direction, I can write xy as xq plus qr plus ry. Does make sense. X to p, p to s, s to y means x to y. Do you see that? X to q, q to r, r to y means x to y. Perfect. Now if I add these two, what do I get? Check it out. xy gives me twice xy. The first two terms, xp and xq. See, xp and xq, if you add them, what should you get? You should get 0, right? Since you know these are the midpoints, and what we know is that px is equal to xq, right? So I could write 0 equals to xq minus px. But if I change this direction, then this becomes negative, right? Of negative. So xq plus xp becomes 0. So what I'm trying to say here is that these two terms add to 0. Similarly, you will see that sy and yr. So sy is moving in this direction, that is in the other direction. Both magnitudes are same since y is the midpoint. Perfect. And therefore, we also know that sy plus ry is equal to 0. So this is also equal to 0. Right? What are you left with? You're left with ps plus qr. And that's what you need to prove. So we have 2xy equals to ps plus qr. Now whenever we write vectors, a straight line will do, arrow like this or that, everything works, right? So either way. So I hope the proof is very simple and straightforward. The idea is, in similar questions, you should see how you can get one term in two different ways. Then same magnitude, opposite directions add up to 0. So that helps to find the solution, correct? Now let's look into the second question. Question number 2 is, the trapezium ABCD has AB equals to A to B is A, BC is B, B to C is B, AD is 3 times P, that means they are parallel also. E and F are points on BC. So on BC we have 2 points E and F, such that BE is to EF is to CF is to FC is M is to N is to 3. Find BE, EF and AF. So the question here is that we have 3 points here. So let us say these points are E and F. These points are such that they divide this in the ratio of M is to N is to 3. Now you need to find what is BE, what is EF and what is A to F. A to F. So let me join A to F also. So what is A to F? That means from here, what is AF? You can always pause the video, answer the question, and then look into my suggestions. Let's see what is B to E. Now BE is in the same direction as BC, right? When I say that BC has been divided into this ratio, what I can do here is that I can divide BC by sum of these, so we get M plus N plus 3, right? Now BE is M times that ratio, is M times this ratio. Do you get it? So that is how we can get, using scalar multiple, what BE is. Similarly, E to F is nth ratio of the whole, n out of whole, right? So it's kind of fractions. So we can say E to F is, it's good idea to write the scalar multiple first. So I'll write this as n over M plus N plus 3 times BC. Does it make sense, right? So let me rewrite this also as M over M plus N plus 3 times BC. Now what is AF? AF is AB plus BF. So that is what we mean by linear combination. AB is A, so I'll write A here, and B to F. B to F is, now we are taking M plus N as the combination. Do you see that? So it is plus M plus N over M plus N plus 3 times BC. Perfect. So that is how we can actually get the vectors BE, EF and AF in this scenario. So I hope the steps are very clear. We'll also see how we could internally and externally divide vectors in the next section. And there we are going to derive this formula. I hope that makes sense, right? Let's move on to question number 3. Question number 3 is the test question on properties of vectors. I've seen this question many times in test papers. I'd like you to pause the video, answer the question, then look into my suggestions. Question is, if A has coordinates 1, 2, 3, minus 1, 2, 3, so the coordinates are minus 1, 2, 3, and B has coordinates 2, 4, 6, find position vector D which divides the line AB in the ratio of 1:2. When I say position vector, we say OD, right? So from origin, we want to find this position vector. That's the whole idea, right? So as you can see here, that if AB has 3 parts, 1 plus 2, let us say, is 3, right? So if I divide this line in 3 parts, then A to D is 1 out of 3, correct? So what I can do here is, we can say A to D is 1/3 of AB. A to D is 1/3 of AB, so which I could write as 1/3 of A to B, means 2 minus 1, which gives me 2 plus 1, 4 minus 2, 6 minus 3, which is 1/3 of 2 plus 1 is 3, 4 minus 2 is 2, and this is 3. Is it okay? So what you get here is that AD is equal to 1, 2 over 3, and 1. This is what A to D is. We need to find what OD is. So OD can be written as linear combination of OA and AD. So it's OA plus AD. Correct? Now OA is we can write this, we'll write it here, right? So O is origin. O is origin, which is 0, 0, 0. So that minus this will give us that value. So OA is a position vector, right? So it is OA is minus 1, 2, and 3. AD we just calculated 1, 2 over 3, and 1. So if you add them up, you get 1 minus 1 is 0. And when you add this, 3 plus 2, 6 plus 2, 8, right? So you get 3 times 2 is 6, 8. Or let me write like this. 2 plus 2 over 3. And here we get 3 plus 1. Okay. So we could write our answer as 0. 3 times 2 is 6. 6 plus 2 is 8. So 8 over 3. And 3 plus 1 is 4. So OD is that. So we get our answer as position vector D will be 0, 8 over 3, and 4. So I hope you understand and appreciate these steps. That is how we could do it very easily. That brings us to the end of vectors properties. We did linear combinations and a couple of test questions. I hope you appreciate and like it. Feel free to write your comments, share your views. And in the next section, we'll see how to find such points which internally divide vectors into ratio of m:n. We'll also see external division. Thanks for watching and all the best.